Question 9. An object is formed by rotating the curve y is equal to 6x over 3x cubed minus 1 between x equals 1 and x equals 2 through 2 pi radians about the x-axis. And there we can see the curve at the top, that is our function 6x over 3x cubed minus 1. Now when we revolve that round the x-axis, we get this quince-shaped object here. And we are asked, using substitution u is equal to 3x cubed minus 1 or otherwise find the exact value of the volume of this object. So we're asked to work out the volume bounded by a surface. But before we do that, it's a good idea to work out how we worked out the area under a curve between the curve and the x-axis, where the curve is just f of x. Well, what we did, so we drew f of x. Then we divided the space between f of x and the x-axis into an infinite number of tiny wee thin rectangles with dx and height f of x. And if you added up all of those, and that's the same as integrating, if you add up all of those between two limits, you get the area under that curve, between the curve and the x-axis. That's the exact same as saying integral of f of x dx between two limits. Now we're asked to find the volume bounded by a surface. So the question is, how do we go from an area bounded by a curve to a volume bounded by a surface? Well, let's take this in. So suppose we've got a function f of x, some curve f of x. And we rotate that f of x around the x-axis through an angle of 2 pi. That's one complete revolution. We end up with a volume bounded by a surface. What's the value of that? What's the value of that volume? Well, proceed like this. Imagine we take a cross-sectional area of that volume at any point x, cross-sectional area at any point x. That cross-sectional area will always be a circle, and it will always have an area pi f of x squared, similar to pi r squared if it's a circle. Pi f of x squared, if x, remember, can be any point. If we multiply that pi f of x squared, which is an area, by dx, we have a tiny wee thin cylinder on our hand. And it's by adding up all the tiny wee thin cylinders that we get our volume. And that's how we proceed. So, we're no longer integrating f of x dx, that's going to give us an area. We're going to integrate pi f of x squared dx, and that will give you your volume. So if you've got the function f of x, we have to square it, multiply it by pi, and that's what we integrate over our two limits. So to find the volume bounded by our surface, we integrate this expression, pi times integral from 1 to 2, 36x squared all over 3x cubed, take away 1, all squared dx. Now that looks like a difficult thing to integrate. But by virtue of squaring our initial function, we find our squared function in a convenient form. It is in the form f g of x times g dash of x times dx. Because it's in that form, we can use a u substitution, the famous u substitution, or a change of variable, to get into an even simpler form, which is f of u du. And we're already told that u is, the first substitution, u is equal to 3x cubed minus 1, as per the question. It's given us that help to start with. Differentiate that with respect to x, then we have another expression that can easily be substituted in, as we shall see. And we end up with this integral to integrate 1 over u squared du, which is very, very easy to integrate. So we went from a complex integral to a very, very simple integral, making appropriate substitutions. And we go through the whole process and we get the answer to the volume bounded by our surface.